Not slide 6, page 6.
Okay, so listening. So, does anyone remember what we learned about last session on Tuesday?
Yep.
What was it, Attila?
Like graphs and trends.
Trends, good. So, what are the two types of trends that we learned about?
Downward trend, upward trend.
Okay, downward trend and upward trend, good. Yeah, so when we're looking at trends, those are the two definitions that we're looking at. Yeah? Downward meaning all the dots sort of lead down, upward meaning they go upwards. Yeah? And what do we use the trends for? What are they for? You remember what do we do with the like some there's a word starting with P and you kind of tell them what's happening in the future.
Predicting.
You're making predictions.
Oh, yeah.
Yeah, it's all about making predictions when it comes to trends. So I've printed this booklet. It's in the printer downstairs. So it's all about making predictions based on what's happening with the trends. There's also a name for the graphs that we use starting with T. Starting with T. Something series graph. Time series graph. Yeah, so we're looking at data over time. And you're also looking at the trends. Yeah, so that was a bit of a recap of what we did last lesson. This session, we're going to look at now a scatter plot. So for now, set aside the lines of your time series graph and just focus on your scatter plots. And we're going to look at specifically because we're focusing on bivariate data graphs. Yeah, so graphs that have two data that you can work with. Say that again. What does the graphs? Well, that's what a scatter plot is. So this session, what I'd like you to be able to do is to be able to draw a scatter plot. So we've already known that when we're looking at a scatter plot, that you look at two variables, so that's fine. But today I want you to be able to draw the graph. Now you've probably done a bit of it in your lines, so that's good. So it shouldn't be too hard. And Elliot is right, they will look messy. Because the nature of data is it's never going to be a straight line all the time. It's going to look messy, and that's normal. I want you to also be able to, Cohen, you know how we talked about trends, yeah? Now, instead of trends, we're going to be able to describe the correlation, which is similar to the trend. So remember the trend you're kind of talking about, is it going up or down? When it comes to correlation, it's very, very similar. Is it going up? Is it going down? How spread apart are the dots? How close are they? And then I want you to be able to make a scatter plot and identify if there are any outliers. Okay, so everyone knows what outliers are in univariate. There are also outliers in bivariate. Does anyone remember what is an outlier in univariate data? Yes, Sam.
It's a number that is significantly higher or lower.
Good. So number that's significantly higher or lower, or in other words, it doesn't belong with the data. It's the same with bivariate data. There are outliers, although there's no clear way or there's no specific way of determining them. You just have to look at it and see if there are any specific outliers. So let's have a look. So remember, univariate data, what kind of tables do we have? Frequency, histograms, 5-number summaries, and box plots. They're all univariate, yeah? You're working with data, you're finding mean, median, mode. But when it comes to bivariate data, it's a little bit different, yeah? This is what bivariate data will look like. You've got a scatter plot. Okay, it looks messy, dots all over the place. You've got what we call an X and Y table. Okay, and we use the X and Y table to plot the dots on the graph. And you've also got a linear graph. So this is where you have straight lines. Okay, and then we'll go through that later on. But our focus today will be on these. A scatter plots and an X and Y table. So go with me to this page where it says scatter plots if you're not already there. Okay, so scatter plot is basically two bits of data put together because remember this is bivariate. Two pieces of data that we're reporting and reporting it one against the other. And generally speaking, there's a connection between the two bits of data, whatever it might be. Alright, so one could be your age versus your height. They're connected somehow. Another one could be the number of hours you've studied and the mark that you get for your SAT. There's a connection there. Or another one might be amount of hours you exercised, and maybe your fitness level or your weight. Okay, that's all connected. So when we're looking at bivariate data, there's a connection between both variables. So you can see here. Okay, can anyone tell me what are the two variables in this graph here? Height and weight. So what does that graph look like? What does it say? Can I ask maybe Kira? What do you think the graph is saying with height and weight? Yeah, so the taller you are on the height scale, the more you'll probably weigh. Okay, not always the case, but normally that's what happens. Yeah. What about over here, Celine? What are the two variables in this graph? Test results and what's the other one? Hours spent gaming. So let's see, Charlotte. What does this data suggest?
That more time you spend gaming, the less score you get.
Yes, the more time you play games, the lower your score might be probably. Probably. Okay. Okay. All right. Oh, before I actually move on, can anyone maybe see what is a possible outlier in this data? The bottom right, yeah? Could be an outlier. We don't know 100% for sure, but it means that because this guy spent maybe about, I don't know, 90 hours playing games, he really did really bad. Okay, so understand, yes, so when you're looking at data, you need to be able to interpret it like that and say, all right, I can see that this graph is saying, like what I think Kira said, the more weight or height a person has, the greater their weight potentially. Okay, or as Celine mentioned, the more they play, the lower their test results. So when it comes to scatter plots, there's a couple of ways we need to try and interpret it. So like with trends, scatter plots also have a way of interpreting. There's two things we need to look at. Okay, we look at strength and direction. So when we talk about correlation, you're just interpreting it or coming up with a way of how the data connects together. So what's the connection there? There's two things that you talk about. So strength, these are your three options. No correlation, weak, moderate, or strong. So I said three, it's four. No correlation, weak, moderate, or strong. There's four ways that you can describe the strength. Okay, so keep that in mind. That's for strength. What do you guys think that might suggest? I ask you, what does no correlation, a weak correlation, strong or moderate correlation mean? Yes, Jai. Yeah, so if it's strong, that means they're very connected. Yeah, very good. And you guys already kind of know this. What do you think the direction might mean? Positive or negative? Upward or downward? Exactly. So if it's positive, that means it's upward. If it's negative, that means it's downward. Okay, so try not to get this confused with time series though. Yeah, so when we look at scatter plots, this is what we use. Time series is just the trend. You don't talk about the correlation for time series. So just don't get them confused, please. So let's practice this, and this will be blank in your notes. For that first one here, I'm going to ask Esteban, can you describe what the points look like here? Is there a direction? Does they look together? Are they spread apart? Or is it really random? Very random. So when they're very random, we'll write no correlation. Okay, sorry for the bad writing. But we write no correlation for that one. I'll fix that up. So whenever you get data that's just a bit too crazy, you don't really see a clear direction. It's very spread apart. Or it might be together, but just all over the graph, there's no correlation. Okay, so the second one here, Tommy, what do you think this one might be? So we're talking about the strength, yeah? So are they really close together, or they're quite spread apart? You reckon it's middle?
Yes, moderate.
I would say this one is weak. Okay, we'll count, because if you compare it to the next one,
If we look at the one on the left, is weak.
no, this one is no correlation because it's really random. This one here would be weak. If you go here, this would be moderate, yeah? Because good, so we get it. The closer the dots, the more strong it is. So this is moderate. And the last one, as Jai mentioned before, When they're really, really close, you can kind of see that it's going to make a straight line. You would say it's strong. Okay, so those are the 4 options for strength. No correlation, just random. Weak, they're kind of close together, but not really. Moderate, they're a bit closer. And then strong is when they're very close. I think in year 10, we might just test you on whether it's strong or weak. Okay, those are the only 2 things. But in year 11, just keep in mind that they do add weak, strong, and obviously no correlation. So keep that in mind, yeah? Strong or weak are what we'll probably test you on. But moderate will be somewhere in between. So that's for strength. All right, let's look at direction. Really easy, yeah? Steph, have a look at the first one. What direction would this be going? So it's going upwards. So you're reading it from left to right, yeah? What direction is it going? Up. So if it's upwards, it would be, starting with P, positive. Good. So if it's upwards, it's a positive trend. Okay, and Cohen, if it's going downwards, what would it be? Negative. Good. Okay, those are the only 2 directions you can really have when it comes to direction. If it goes sideways like that, technically there's no trend. Yeah, so you can just leave it as is. All right, let's look at these as examples. Okay, we're going to state what's the strength in the direction for both of these. Abby, I'm going to start with you. Can you tell me what would the strength be for this graph? What would you say? If I gave you the option of strong or weak, which one would you say? Or okay, we can say moderate. So let's say it's moderate. I like that. Moderate's good. And then let's see. Georgie, can you tell me the direction that the graph is going? Is it positive or negative? Good. So it's a moderate positive. Now in year 11, we get you to do this moderate positive correlation. Relation between between weight and height. Now, this is in year 11. In year 10, we don't expect you to do this. Okay, but I'm just teaching it to you now so you know what to expect next year. Moderate positive correlation. So what I'm looking for bare minimum is these. Moderate positive correlation. You don't have to write the rest of it, but in year 11 they do ask you. Yes, keep that in mind. All right, just wait. Next one, Donnie. What's the strength of this one? What do you reckon? Yeah, I would argue that it's strong. Although it does look like towards the bottom, it does spread out a bit. But for argument's sake, I'm going to say it's strong. And it's negative direction. Thank you. Negative. Correlation. Yeah, so bare minimum, just write correlation in the end.
Well, Mister, what was the direction?
The direction should be negative because it's going down. For the second graph, Tommy. The second graph. Let's see. Who have I picked on yet here? Van, what do you think the outlier might be here? The one on the very bottom, yeah? Now, I haven't quite told you guys yet, but this... Okay, let's point it out. Possible outlier. Sam, can you tell me what coordinate do you think this outlier might be? What do you think it would be? So when we talk about coordinate, what's the amount of hours this person spent studying and what would their score be based on that dot?
85. Probably like 85 minutes per arrow.
Yeah, 85. So 85 hours spent gaming, and then what do you think that test result might be?
About like 10-ish, 15.
Yeah, 10, 15. I might say 15. And Charlotte's, I think you're closer. Let's say it could be probably be 92. It doesn't have to be exact because it's very hard to tell. Just make sure in the sack that you're in the ballpark. Yeah, don't say it's 80, for example. Or don't tell me that the score was 30 because that's not correct. Make sure you're within a specific range with that. All right, so that's pretty straightforward. Let's go through the other more correlation examples here. This one here, As you can see, no correlation there. It's all over the place. Okay, pretty straightforward, I think. This one here, again, would also be weak negative. And outliers, I also sort of mentioned it already before, but there's an outlier. Here is a possible outlier as well. Okay, let me see. Akela, what do you think the coordinate bit would be for this outlier? Have a think. Try and line it up. So what would their kilometers and their weight be? Good. I would argue it's 7 kilometers, and what would the weight be? Probably 90, yeah. I'll say it's 90. Okay? Easy. I think it's 7, yeah. But if you said 7.5, I would probably still take it. It's kind of hard to tell, but that's all right. Alrighty. Let's do some examples and plot some of these graphs, yeah? Okay, so now we're going to look into some plotting. Now, you've probably done a bit of plotting in your previous schools, so this might just be a recap for some of you. That's okay. Alright. So here, you've got an X and Y table. Remember, bivariate data, X and Y table. It's not the same as the other stuff we learned in univariate. So we need to do, in this X and Y table, draw a scatter plot. Okay, easy. We need to describe the correlation. So is it positive, negative? Is it no correlation? Is it moderate? Or is it weak or strong? And then we need to identify if there's any outliers. All right, let's do it. So generally speaking, when we do these questions, we will draw the graph for you. Okay, but understand in year 11 and year 12, you need to draw the actual table yourself. Okay, so I'm going to be nice in the stack. I'm going to make sure these are drawn. But what I'd like you to do is draw the scatter plots. If you're confused about that, okay, this is what we mean. So if you're trying to plot x2 and y19 on my graph, remember this is my x-axis, that's my y-axis. So if x was 2 and y is 19, I'd go 2 down here, and then on the y, 19 would be over here. That's the first one. Next one is 3, 6. All right, so x on the 3, y on the 6 would be over here. Next one, 3, 17. So x on the 3, 17 on the y is about here. Okay, do we get it?
Yeah.
I'm going to let you guys do the rest. Keep going. Actually, I'll leave that there. Let me pause this. Let me get rid of this. Look, magic trick, guys.
Oh, Mr. There's an outline.
Whoa! All done. Okay. There is going to be an outlier, yes, but let's not talk about it just yet. So your graph should look something like this, yeah? Something like this. Just don't forget, in your graph, in the SAC, you need to label your axes. I've done it here for you, so I've called this X, and that's Y. But we'll go through more examples later on, but just make sure you label the axis. Yeah, they are very, very pedantic about it in year 11. All right, next question. So go to the next question here. We're going to describe the correlation. The graph's not in your book, but you can have a look at it here. Let's describe the correlation. So we're talking again about the direction and the strength. Let's talk about the strength first. Would you guys say this is strong, weak, moderate, or no correlation? Moderate, strong. So again, in year 10, we only probably test you on 2, whether it's strong or weak. I would argue that this is probably more strong than weak. Okay. I think it's going to be very clear what it is.
What do you mean?
Like, it will make it really obvious what it will be. Yeah. So it's easier to know. Sometimes it's annoying if we do moderate because it is, but I'll talk about that next time, man. So strong, and Attila said negative. Good. Strong, negative. What's the last word? Correlation. Make sure you put that in. Identify any outliers. Okay, let's see. Chris, what's the outlier here, man? So the one that doesn't belong. Which one is it? 3, 6. So, yep, we'll put in brackets 3, 6. Okay, that one right there is an outlier. Okay, let's go to the next. Oh, that's basically it. I think that's that one. Okay, cool. Any questions with that? Pretty straightforward. Most of the questions we'll just expect you to do that. Let's do this one, and then we'll start working. So this page here, worked example, worded example. So a lot of the questions you have in data are definitely going to be worded examples. So you've got to get good at interpreting what it's asking. But here, Mr. Guido recorded the age of height in years, in centimeters of all his family members in the table below. All right, so there's my data. Remember, it's the same as an X and Y table. Yeah, just keep that in mind. There's 4 questions we need to look at. Do we expect there to be any correlation between the heights? So is there a connection between them? Draw the scatter plot, describe the correlation, and then is there any value that might be an outlier? Okay, so first things first, we need to answer this, and I want you to write it in there. And because I did mention before with the time series graph, you're going to get questions that aren't necessarily mathematical. It's going to ask you these sorts of questions. Okay, so do you expect there to be, when we say correlation, any connection? Elliot, I'm going to ask you, do you think there's going to be a connection between height and age? Yeah? What's the connection there? What would you describe it as? So you're right, it's yes. But how would you justify it? What would you say?
What, as in with like the width?
Well, justifying, like, maybe think like in real terms. What happens when someone's older?
Oh, they get short. Oh.
They probably grow taller. So you would say, as
That's a good made.
people get older,
To be fair, when they get really old,
they grow. Now, I did mention, remember, you're going to get questions that aren't necessarily mathematical, but you need to talk about these things, yeah? One of the other questions we had was, I think with the previous time series question was, do these temperatures belong in Australia? Yeah, I think it said in the middle of the year of that graph, the temperatures were really high. Start of the year, they were really low. Yeah, so you'd have to try and think about those sorts of scenarios. Which one? As people get older, they grow taller. Okay, normally speaking, yeah? Except maybe when you get old, which is like me, starting to get short. Starting to.
Cheating.
All right, so that's what we would say. Yes, so there's going to be a correlation. All right, next question, guys, is I want you to now plot those age and heights. Yeah, so go ahead and do that. I'll pause this. All right, let's answer the last few questions, and then you guys can start working. Yeah, so again, in the SAC, Esteban, can you sit down, please? In the SAC, yeah, keep in mind to make sure to label your axes. I've done it here for you. But in the x-axis, it's normally age, and in whatever the value is after is the y. Just keep that in mind. I will go over it again later, but that's okay. All right, Esteban, actually, I'm going to ask you, what is the strength of this? Would you say it's strong, moderate, weak, or no correlation? Moderate. I'll take moderate. Very good. And what is the direction? Positive or negative? Negative. Positive, guys. It's going upwards. Although, generally speaking, if you were to draw a line for this, it would probably look something like a curve. Yeah, it doesn't look like a straight line. It's a curve, but we'll leave it at that. All right, next question. Are there any values that might be outliers? Okay, does anyone find the 2 possible outliers here? Yes, Chris, what was one of them?
I'll go with the
032. Okay, that's what?
77, the one.
Good. So let's circle them here. And I want you to write the coordinates. So just practice doing the coordinates for it. You can use your data from the table, but I think it was 032. And this one here was it 77, 156? Yeah. So just practice doing the coordinates for it. So in your answer, you would write yes, 032 and 77, 56. 156, sorry. Possible outliers. Okay, and you got to come up with an explanation, yeah? Not necessarily going to be a mathematical question, but you got to tell me why. So, The 032, you could say that it's probably a what, Elliot? Yeah, what is that? It's probably a baby. Yeah, so you'd write 032. Probably a baby. And then what would 77 156 be? An elderly person. Or elderly person. Are you going to the toilet? Go for it, buddy. You can go. Thank you. And that's basically it, guys, when it comes to scatter plots. Yeah, let me see. Any questions?